Okay, welcome everybody. This is going to be probably a short trig unit. Okay, we only got, a certain amount of time, so I'm going to try to cover the important parts of trig and the stuff you need to remember in order to carry you into Algebra 2. Okay, now a lot of times kids forget this, and we are in the middle of a play or a pandemic here. Chances are there's a good chance you might forget a lot of this stuff too. But that being said, okay, I still want to, go through some of those parts because it's going to be important to your guys' project. So, warm up. So find the missing side. Okay, so what do you have to use? Well, all right, what do we have to use? Well, I see a right triangle here, right? We know it's a right triangle, so it's got that symbol right there. Okay, and so in order to find the missing side of a right triangle, okay, we are going to use Pythagorean theorem, which is a squared plus b squared is equal to c squared. Okay? So, that being said, right, the first thing you're going to want to do, actually we'll get there. All right, I'm getting ahead of myself. Let's talk about this triangle right here. So to find this missing side, okay, you can always kind of mix up these a's and b's, but we got to remember that this c value is always the side opposite your right angle. Okay, so this is what we call the hypotenuse. Whoops. Hypotenuse. Okay, it's a hypotenuse leg. It's always located directly across from your right angle. Okay, so you can mix up your a's and b's. So I'm going to make this one a, this one b. Doesn't matter because addition is commutative. Okay, so I don't know what a is. So a squared plus 10 squared is equal to 26 squared. Okay, so this is going to be a squared plus 100 is equal to, and I don't know, 26 is. But 26 times 26 is 676. Okay? And to find a, you subtract 100. You get a squared is equal to 576. I think that is, oh gosh. I feel like I've seen this number before. Our square root of 576 is the square root of 24. All right, so you take the square root of that, and you get a is equal to 24. Okay, so the length of this leg right here is 24. Okay? And we call these Pythagorean triples. Okay? And they're written like this. 10, 24, 26. Okay? Which basically means that these two numbers squared equals this third one. Okay? And you get nice numbers. That's what it means to be a Pythagorean triple. Okay? And it's going above and beyond, but it's important to remember that number, or what that is, just in case. It just means you have nice numbers for all of your legs. Okay? Pythagorean triple. So, trigonometry is the study of the relationship between sides of a triangle and its angles. Okay? So that's what trigonometry is. It's just the relationship between the sides and its angles. Okay? More importantly, all right, we're talking about right triangles. Okay? So, for a lot of you, this is all new. For some of you, you might have seen this before. Okay? So, sine functions. Okay, so let's just say this is theta. All right, so let me write these in here. So let's say this is theta. This would be our hypotenuse. This is our opposite angle, right? It's our opposite side. It's opposite the angle in question here. Okay, in this case, we always write our angle as theta. Okay, so theta, all right, is our angle here. And then the closest side to that, we call that the adjacent. So adjacent, opposite, and hypotenuse. Hypotenuse is always that side located directly across from your right angle. Okay? And then the opposite and adjacent switch depending on where this theta is located. So if theta was located up here instead, well then this would become your opposite. This would become your adjacent. Okay? It's the side that's touching the angle in question. Okay? And they always notify which angle they're talking about. All right? So sometimes they'll have it labeled theta, and sometimes they might actually have a number in there. Sometimes they might actually have, I don't know, 45 degrees. Okay? So whatever angle they give you, that's what you base these other sides on here, these opposite or adjacent. Okay? So sine stands for opposite over hypotenuse. Sine of theta. Why am I writing this over here? Okay, so let me just write this up here. So sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Okay? So this is what your trig functions look like. All right? So what this means is to find this angle measure, you're going to take this side and divide it by that side. Okay? And we'll get into further of these problems. But you just have to remember this is what these trig functions look like. Okay? So let me shorten this one up top here. Okay, so you're going to have opposite over hypotenuse. Okay, so it's just O over H. This one is A over H. And then this one down here is O over A. Okay? And so there's a different ways you could try to remember this. Okay? We were always taught so, ga, toa. Okay? That's one way you could remember. And I've also heard Mr. Kenyon use this, so I'm going to use it. You can also refer to this as some old hippie caught another hippie tripping on acid. Okay? Maybe it's not the most appropriate way to remember these things, but this is kind of how it was taught to me. And as long as you're not using any of those things, I guess you should be okay, all right? But basically, you can remember it in two ways. Sokotoa, or some old hippie caught another hippie tripping on acid, okay? These are just a couple ways you could try to remember these trig functions, okay? Now, if you look at the reciprocal functions, okay, this is just 1 over sine of theta. This is 1 over the cosine of theta. And this is 1 over the tangent of theta. Okay. Also, tan can also be written as sine of theta over the cosine of theta. Okay. You're going to have to remember that one as well. So that means that these are actually just, they get flipped. So this is H over O. This is H over A. And this is A over O. Okay. So those are just reciprocal functions. Okay. And I came up with these because you just got to remember that keep, flip, change thing. So what happens is when you reciprocal these trig functions here, they just kind of get flipped. Okay? So, I guess I was supposed to write this down here. My bad. This is going to be sine of theta over cosine of theta. And this is going to be just flipped, cosine of theta over sine of theta. Okay? So one way you could try to remember these things is that sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. Okay, so just kind of remember just the opposites. The S goes with the C goes with the S, and so on and so forth. Okay, but you got to try to remember what those things are. Okay, so let's get into some examples here, because I feel like we've just been talking a lot about what these functions look like. Let's see what they actually do. Okay, so we take a look at this first picture. Now here's our angle in question. Okay, we don't know what it is, right, but we know how we could find it. Now, another issue is we don't know what that is. So in order to find that, we're going to have to use Pythagorean's theorem, which is going to be 1 squared plus the square root of 3 squared is equal to c squared. And this is 1 plus 3 is equal to c squared. So we get 4 is equal to c squared. Take the square root, and you get c is equal to 2. So this length right here is just equal to 2. Okay? Now hang with me, guys. Once we start getting to the math here, you'll see a little more behind these functions here. All right, so the sine of theta, remember, is equal to some old hippie. Okay, cosine is caught another hippie, and tangent is tripping on acid. Okay? So, here's how we find that. Okay, we go up to this angle here. And I always try to label these things. I can't help it. I'm old, and it's just nice to have things labeled. So our hypotenuse is always the side that's opposite our right angle. So we're good there. But now we need to label these two sides here. So if you look, 1 is not touching the angle, so that is our opposite side. And square root of 3 is our adjacent side. Okay? And so now we just have to fill in the blanks. So the sine of theta, so it's going to be 1 over 2. Adjacent over the hypotenuse is going to be square root 3 over 2. And opposite over the adjacent is going to be 1 square root of 3, but we cannot leave a radical in the denominator, so we multiply the top and the bottom by radical 3 over 3. We get a radical 3 on the top. Two radicals cancel on the bottom. Don't forget, when you multiply, anytime you multiply a radical times a radical, and you have the same number underneath that radical, those radicals cancel, and you're just left with whatever number is in there. So in this case, square root 3 times square root 3 is just equal to 3. Okay. And so now we need to find out what this angle is. So this is where I was going to talk about going to your calculator. And I want you to go to your mode. So go to the mode. Should be at the top. And your third option down, you should have the thing selected radians. Right? So you're going to not select radian. So radian should be selected. Right? So that's the third option down. So you're going to go to radians. And you're going to click over and select degree. So now that your calculator is in degree mode. So let me write that in there. We need to switch to degree mode. Okay. All right, so now in order to find what this angle is, okay, so let's just take a look here. We got sine of theta is equal to 1/2. All right, so the question is we got to get rid of this sine here. So in order to get rid of this sine, you need to multiply each side by the inverse of sine. Okay, so you can do this for sine, cosine, or tangent. It really doesn't matter. I'm just using sine because it's the first option. So once you're in degree mode, okay, you go and you got sine of theta is equal to 1/2. So to get rid of that sine, okay, you're going to take what we call the arc sine, okay, or the inverse. So what you're going to do is you're going to click the second sine. So you go second, and you click sine. All right, and you should get a sine with a -1 parenthesis. Okay, and once you get that, you're going to type in your 1/2. So the sine, or the arc sine of 1/2, and you should get 30. Because we switched this into degree mode, this is actually 30 degrees. So what we just found, based off the sides of this triangle, okay, is our degree measure of that particular angle. And you can try the same thing for cosine or tangent. So let's just go second cosine. And in this case, we're not going to type in 1/2. We're going to type in square root 3/2. Whoops, made a mistake there. Oops. All right. So if you type in second cosine, so you should get a cosine -1, and you type in this right here. Now again, this is in degree mode. You should also get 30 degrees. And last but not least, if you want to try the tangent, all right, square root 3/3. Type that in. So second tan, so you should get tan to the -1. We're going to go second square root 3 divided by 3, and voila. For each case, we get 30 degrees. Okay? So that should give you some sort of comfort that no matter which one of these things you use, you can still use it to find the angle, just as long as you take what we call the arc sine. Okay? So what we're doing here is we're just kind of canceling out that sine, and then you should be left with theta. Okay? So let me write this down. So what happens is the sine goes away, so you're left with theta is equal to whatever that degree measure is. Okay? So let's try the next one. Right, here is our angle in question. Okay? And so this is our hypotenuse. Here, this one's going to be adjacent because it is touching the angle. And this one is opposite. It is not touching the angle at all. Okay, so the sine of theta is some old hippie. Okay, so in this case, whoops, I don't know why I just took that out. Okay, we need to find out what this opposite side's length is. Okay, so we're going to go 4 squared plus b squared is equal to 8 squared. It's going to be 16 plus b squared is equal to 64. Subtract 16. You get b squared is equal to 48. Take the square root, and b is equal to the square root of 48. Okay? Now, we could simplify that radical, but it's not asking us to here, and I'm not too worried about it at this point in the game. So this one's going to be square root of 48. Okay? Yep, I like it. All right, so let's keep going here. So this is caught another hippie tripping on acid. Okay, so there is our sine functions. So let's just start filling this stuff in. So our opposite, square root of 48 over our hypotenuse, which is 8. Our adjacent is 4 over 8, or just 1/2. Then our opposite over adjacent is going to be square root of 48 over 4. Okay, now these certainly do break down here. Okay, we could simplify those radicals. And let's do so anyway. Might as well. All right, let me go up here real quick. Let me simplify this radical. So square root of 48. I'm going to do the prime factorization, the hockey trick. All right, so 2 times 24, 2 times 12, 2 times 6, 2 times 3. Here's our hockey stick. Pair of twos, pair of twos. Okay, so you see a pair, pull it out. See a pair, pull it out. Left with the square root of 3. And so our answer is 4 square root 3. Okay? So if we put that in there, let me take that out. Okay, and then you'll notice what happens here is that some of these things cancel. So let me shrink that up there. Okay, so this is equal to, okay, you can simplify that. So we're going to have square root 3 over 2. And this is going to be the square root of 3. Okay. So, our last problem here is we've got to figure out what theta is. So, we can use any one of these. I'm going to use cosine this time. Okay? So, I'm going to go cosine of theta is equal to 1/2. Right? So, in order to get rid of that cosine, it's always like doing the opposite, right? You always got to do the opposite. When you want to get 5 on the other side, you either add or subtract it. This time, I'm just taking the negative cosine of 1, or our arc length. Okay, call it the arc cosine, if you will. Okay, so again, you're going to go to second cosine. So by hitting second cosine, okay, second cosine of theta, you'll get that cosine of negative 1 of 1/2. Make sure you're in degree mode. When you plug that in, you get 60. Whoa. Okay, so theta is equal to 60 degrees. Okay, and you can do that for all of them. So if I did second sine of square root 3 divided by 2, you get 60. Second tan, in this case it's just the square root of 3, so second tan, and you get 60 as well. Okay, so make sure you guys ask these questions when we have the session here, because it's a little, if I can't show you directly, this part will be a little tricky kind of listening through. So to solve these, you have to use the second cosine or the second sine button. Okay, so anytime you see a problem like this, cosine of theta is equal to 1/2. In order to solve that, you need to take the, the arc cosine, or the cosine of negative 1. And what happens? These cancel, and you're left with theta is equal to cosine negative 1 of 1/2. Okay, that's what you have to do. All right, let's keep going here. Okay, I wasn't really sure if I should include this on here, but we've dealt with complementary, so we know what that means. And I kind of figured we'll just keep hitting on what it means to be a complementary angle. So, what this means is, okay, to be a complementary angle, okay, you need to have the measure of angle 1 plus the measure of angle 2 is equal to 90. Okay, that's what it means to be two complementary angles. Their measures add up to 90. Okay, so you look at the sine of 70. All right. The trig value of an angle will equal the cofunction's trig value of the complementary of that angle. So the complementary of 70 degrees is 20 degrees, Okay, but we want to include the co-function's trig value. So go back up to the top here. Okay, so our co-functions are sine and cosine. Okay, or there is, well, we'll start with the sine and cosine part. Okay, so going back down there. So this problem right here, right, the co-function of sine is cosine, and you're just going to put the 20 right in there. So if you were to go to your calculator, type in sine of 70, and make sure you're in degree mode. Okay, you get 0.9339 or 9396. Take the cosine of 20, and what do you get? You get the same thing. Okay, so the cosine of 22 is going to be the same as the sine, so 90 minus 22 is 68. Okay, the tan of 40 is going to be the cotangent of 50. Secant, so the co-function of secant is the cosine of 80, and the cotangent of 32 is the tan of 58. So when I say co-functions, well, actually, whoops, I made a mistake here. This is going to be cosecant of 80, sorry. So it's like that co-function, right? So like the co-function of sine is cosine. The co-function of tangent is cotangent. The co-function of secant is cosecant. Okay, so that's what it means by co-functions. So let's just verify here, all right? So if I want to do the tan of 40, so the tan of 40, so plug that in your calculator. Tan of 40 is equal to 0.8390996312. Okay, we got to remember cotangent is just equal to 1 over tan. Okay, so I'm going to go 1 divided by the tangent of 50 degrees. And if you type that into your calculator, you still should get 0.8390996312. Okay, same thing with tangent here. Okay, so 1 over, because that's what this is 1 over tangent. 32 is equal to the tan of 58. So the tan of 58 is 1.6000. Okay, and the cotangent, so it's going to be 1 divided by the tan of 32, and what do you get? The same exact thing. Okay, so that is all we're doing for those. We're just kind of looking at what it means to be complementary and just kind of switching between co-functions. Okay, so it says last year, okay, ignore that part. Okay, this is all new to most of you guys. And this is going to be pretty difficult, so make sure you guys bring in these questions. All right, so find the variable to the nearest tenth. Okay, so find the variable to the nearest tenth. So, in this case, they give us our angle measure, which is 37. This is our hypotenuse. This is our opposite. And this is our adjacent. Okay, so find the variable to the nearest tenth. So in order to find this value right here, okay, we have to use the particular function that involves our hypotenuse and our opposite. Okay, so let's think about this. So we're going to go ga toa. Okay, so which one of these deals with our opposite and our hypotenuse? Okay, you should be selecting sine here, because sine theta is equal to opposite over hypotenuse. Okay, So that's what we're going to use here. We're going to use the sine function. Now let's start filling in the blanks here. Let me shrink this up, kind of zoom in here. Okay. So in this case, we do have a function. We do have a degree measure, so it's going to be sine 37 is equal to, so our opposite is 11, but we don't know what our hypotenuse is. Okay? And so make sure you're in degree mode. So we're going to go sine 37. So this is going to be 0.60181 50232 is equal to 11 over x. Okay, so to get 11 by itself, I'm going to multiply both sides by x, and then you're going to get this big number here. So I'm just going to put sine of 37 times x is equal to 11. I don't want to write that big long number, but then I'm going to divide by the sine of 37. And so x is equal to 11 divided by that last answer. You should get x is equal to 18.27. This is round to what? The nearest tenth. So 18.3. Okay? That's what this side should equal. Okay? And that's all we have to do for that particular problem. So let's go over to the next one. So here's our angle measure. So this is our opposite. This is our adjacent. And here's our hypotenuse. And we want to find this one right here. So we got to think back to which one of our functions. Let me write this up top here. So TOA involves opposite and adjacent. Oh, that's tan. Okay. So they give us our degree measure. So the tan of 42 is equal to x over 13. Okay? And so our last part here is we're just going to go tan 42. Whoops, so you should get some number there. Oh, get out of there. Okay, it should be 0.90004 is equal to x divided by 13. And to get 13 on its own, you're going to multiply both sides by 13. 11 point, I'm going to round it to the nearest tenth, so 7 is equal to our x. Okay. Let's keep going here. A few more problems and then we'll call her good. So, yeah, I'm going to skip these ones. Okay, you guys can try them on your own. But for the sake of time here, I want to get to the last part. So, this one right here. This is our hypotenuse. Here's our angle. So this is going to be our opposite. And this one is our adjacent. So going back to our SOHCAHTOA rules. Okay, we're given an adjacent and a hypotenuse. So which one of these involves adjacent and hypotenuse? Well, that's going to be cosine. So the cosine of 20 degrees is equal to adjacent over the hypotenuse, which is 12. Okay. So the cosine of 20, 0.9396926208 is equal to x over 12. Multiply both sides by 12. and you get x is equal to, we're going to round it to the nearest tenth, so 11.3. Okay. All right. So that's what you're going to do for those. Okay. So if you want to bring these questions up tomorrow, we can go through a couple of these. All right, but I want to get to this part down here. Okay. So trig values you need to memorize. Right. So when we're talking about trig, you're going to hear us talk a lot about the unit. Wow, not a good circle. The unit circle here. Okay, so let me pull this up here. Let me draw it underneath here. Okay, so here's our center. It's going to be somewhere right here. Okay, and what we're talking about, at least in these parts up here, is we're talking about angles in our first quadrant. We're talking about angles from this point here all the way up to this point here. Okay, so what we're looking at is the sine of 0. So this is all degrees up here. Okay, so we got 30 degrees. We got 45 degrees. We got 60 degrees, and we got 90. Okay, so what you got to remember when we're talking about trig, and we're talking about points on a graph, is that, okay, we've all seen points written like this, but now they change to this, okay? So these points along our unit circle, okay, are our cosine and sine values. So we don't want to think of x and y as, we want to think of them more or less as sine and cosine values. Okay, so I'll explain what I mean here. So at this point right here, right, another thing to our unit circle, when I say unit circle, it means literally 1 unit. So it means that this radius, our radius for our circle, is 1. Okay, that is our radius. All right. Now, okay, these points along our unit circle are represented still like coordinate points on our graph, but we got to remember this is in reference to cosine and sine. Okay, so our cosine always measures this length right here, and our sine measures our height. Okay, just like our x and y's. Our x's represent our distance along the x-axis, and our y values are still, represented by how high above or below our x-axis along our, as we're going up and down along the y-axis. Excuse me. Okay, so let's go back to this one right here. So our unit circle, which is only 1, okay? So if I were talking about this point right here, it'd be 1, 0. And then this point up here would be 0, 1. Okay? So if I ever said the sine of 0 degrees, well, we'd go look at, okay, this is our cosine, this is our sine. So our sine of 0 degrees, how high did it go up? Well, 0. But what's our cosine of 0 degrees? Well, we look at our x value, and we see that the cosine of 0 degrees is 1. Okay, let's go to the sine of, this would be 90 degrees. Okay, and then it goes 180 degrees, 270, and then back around would be either 0 or 360. Okay, don't forget 0 and 360 serve the same point. They're talking about that point right there. So the sine of, let's say, 90 degrees, well, that one's going to equal 1. So if we look, what's our y value there? 1. It went up 1 unit along our y-axis. So then the sine, whoops, cosine, of 90 degrees. Well, we look at that point right there and we see that that's a 0. Okay, so let's fill in those 2 points first. So the sine of 0 degrees, 0, cosine of 0 degrees is 1, and then tan, don't forget tan is just equal to sine over cosine. And so in this case our sine is 0, our cosine is 1, and so our tan is just 0. Okay. Let's go to 90 degrees. Oops, actually I'll leave that in there. Whoops. Let's go to this one over here. So in this case, at 90 degrees, okay, our cosine is 0. Our sine value is 1. Okay, but then let's talk about sine over cosine here. Well, sine over cosine is going to be 1 over 0, but that's no good because we got a 0 in the denominator, so that means that this value is undefined. Okay, now we can fill in the rest of these. Okay, so you're going to have to memorize these. There's no other nice way to put these. And I'll try to give you some sort of hints in order to help remember. Now, 45 degrees is nice. Okay, so this is going to be 45. Okay, 45 degrees has the same value for its sine and cosine. So the sine of 45 degrees and the cosine of 45 degrees is square root 2 over 2 for both cases. And so our tan, okay, it's going to be square root 2 over 2 divided by square root 2 over 2. Okay, so keep flip change. What's going to happen is that we're going to have two over 2 times 2 over square root of 2. Those cancel, and you're just left with a 1. Okay, so the tan of 45 degrees is just 1. Okay, and again, we get this by doing sine over cosine. Okay, so sine of 45 degrees is 1. Now the cosine, or the 30 degrees and 60 degrees is realistically the only ones you really have to try to memorize. Okay, because if you can memorize these two here, or these three here, okay, you're more than half. All right, so let's finish up the rest of these. All right, so take a look at 30 degrees. Well, the sine of 30 degrees is 1/2, and the cosine of 30 degrees is 3 over 2. And then when you go to 60, it just flip-flops. So the cosine of 60 degrees is 1/2. The sine of 60 degrees is square root 3 over 2. Okay, now again, these are just points on the unit circle. There's actually points out in the coordinate graph here, okay, the coordinate plane. So you just got to remember that these are just x and y values that go around our circle. Okay, so again, we look at the sine of 30 degrees, it's 1/2. Cosine of 30 degrees, square root 3 over 2. And then we got to remember the tan is sine over cosine. So in this case, we get square root 3 over 2 divided by 1/2. Okay, so you're going to keep flip change. Let me give myself some space here. So keep flip change. What cancels? The 2's. And so the tan of 30 degrees is square root 3. Then we go to 60 degrees, we just flip-flop this. So the sine of 60 degrees, square root 3 over 2. The cosine of 60 degrees is 1/2. And then again, we got sine over cosine, So I'm going to bring that over. So it's going to be 1/2 divided by square root 3 over 2. So what's going to happen is you're going to have 1/2 keep, flip, change. So those multiply out. So you're left with 1 over square root 3. But we cannot have a radical in the denominator. So we multiply the top and the bottom by square root 3 over 3. And we get this as our tan value. So our tan value for 60 degrees is square root 3 over 3. Okay? And you just have to remember, you just have to try to memorize these. Okay? Someone came up with these values a long, long time ago. All right? But they're basically found by creating a right triangle at each of these points here. Okay? So that's how they found those values. So don't worry about how I came up with those. Just know that you have to try to memorize these values. Okay? Because when we start talking about unit circle, it'll make things a whole lot easier for you. Okay. So I want you guys to try the homework. All right? I'm expecting lots of questions on this because this is a very difficult topic. So don't be shy if this was very troublesome to kind of follow along with, because trust me, it was kind of hard to teach it without having you guys there. It's nice being able to see some visuals. So any questions on this stuff, make sure you guys come and talk to me. Or, well, can't come talk to me. Bring your questions to the meetings. Okay? And that is your Trig Day, Unit Day 1. Okay, guys. Good luck. Oh, for homework, it's going to be everything down here. Okay? All righty. Good luck.